Hello students, in this video we'll begin our discussion with functions of several variables. A function of several variables, and by this we're going to mean more than one, is a mapping f which inputs a n-tuple and outputs a real number. And so what we're going to focus on is we will focus on a function f which maps two variables into one variable, or a function f which maps three variables into one variable. So we can write down lots of examples of these. So for example, we could have f of x and y, and now I input an x and a y. So this pair x and y is a point in two-dimensional space, R2. And I could output a function like this, x squared y plus y cubed sine x. This function depends on both x and y, and I input two numbers x and y, and I output the sum of these two functions over here, and that will give me a single valued answer. We can look at this type of example. I can look at another example over here. Example, g of x and y is x to the fourth minus y to the fourth over x squared plus y squared. That's a function of two variables. And when I plug in these two variables, I'll output this expression over here. So for example, if I look at g of 1, we'll have 1 to the fourth minus 1 to the fourth over 1 squared plus 1 squared, and that gives me 0. So the output is a real number. We can plug in other numbers to this. If I look at g of, for example, 1, 2, that would be 1 to the fourth minus 2 to the fourth over 1 squared plus 2 squared. And now we see that this is going to be 1 minus 16 over 5. So it's going to be negative 15 over 5, or that's just going to be negative 3. We can also look at functions of three variables. So we can think of these types of functions. So let's do some more examples. So we can look at a function, for example, f of x, y, and z, which is x times y plus y times z plus x times z. That's a function of three variables. And if I was to plug in, for example, f of 1, 2, 3 into this, I would have 1 times 2 plus 2 times 3 plus 1 times 3. So this would be a 2 plus 6 plus 3. So 2 plus 6 plus 3 is 11. Let's do another example of a function of three variables. I look at g of x, y, and z, which is x to the y to the z. So I could plug in the points. I could look at g of 2, 2, 2. That would be 2 to the 2 to the 2. So this would be 2 to the fourth power, and 2 to the fourth power is 16. Now, it doesn't have to be just a function of two variables or three variables. I can go up to higher dimensions if I like as well. That's where I have to start indexing things. So for example, I can look at a function f of x1, x2, x3, all the way up to xn. And so now I have n variables that I've input. And we can do something like this. Let's write this as x1 plus x2 plus xn squared. That could be my function of n variables. Now, it's an important thing to remark about these things that the variables which are input are assumed to be independent. And we'll see this issue of independence comes up later when we begin to discuss the chain rule and figuring out if the independent variables x and y, or x, y, and z, depend themselves on another set of independent variables, u and v, then x and y will become dependent variables. So tracking which variables are independent and dependent will play an essential role when we're studying functions of several variables. Thank you very much.